Hi, hello. Hi, hello. Good afternoon. This is Maruti Prasad Satluru. Hello. Hi, hello. Hello. This is Maruti Prasad Satluru. Thank you. Thank you. Welcome to Unacademy YouTube channel, all of you. Yes. Welcome to Unacademy YouTube channel. This is Maruti Prasad Satluru. I have more than 13 years of experience in teaching chemistry for EAMCET, JEE and NEET students. Okay. And please subscribe this Unacademy YouTube channel and like it as well as share it. And one important subscription page it is, plus subscription with respect to Unacademy. If you are a subscriber, then there is no problem, but if you are not taking any subscription, please take the subscription immediately. Okay, it is very benefit for you. And the benefits are the premium content which is at affordable price, and structured live courses will be there with complete dedicated live doubt clearing sessions. Okay, and after that, so many number of quizzes will be conducted at regular intervals for getting self analysis of yourself, and so many number of batches for complete preparation of the syllabus we have, and test series for daily practice papers, full length mock test with complete analysis will be there. And see here, by taking single subscription you will get unlimited access. It is, but don't forget to use my code, that is Maruti Live. Once you are applying my code, you will get 10% of instant discount. And you can utilize 20 plus top educators, 10 plus batches, 250 plus courses, 2000 plus lessons, and many more will be added every day. Everything is under single plus subscription, of course. And see, one more thing I want to mention here is the Unacademy is giving two best plans for EAMCET 2021 aspirants. One is 12 months plan and the second one is 6 months plan. 12 months plan is for 12,375, whereas 6 months plan is for 10,125 rupees. It is 1000 approximately and it is 1600 approximately. Multiple batches are launching every month. Maruti Live is my code. Once you are applying my code, you will get 10% of instant discount. Okay. See, 6 months full syllabus batch it is and 8 months full syllabus batch it is. As I mentioned earlier, these two are comprehensive batches, out of which one is physics, chemistry and biology, and another one is for physics, chemistry and mathematics. Okay, if you are not enrolling now, please take the enrollment immediately. And one more important thing is the Telugu batch also has been already launched. You can learn from the best educators for EAMCET 2021, and detailed explanation in Telugu language is for better understanding. Complete syllabus coverage will also be there. Wherever necessary, we are giving the tips as well as tricks to you for time save as well as for better score in the examinations, of course. And for this Telugu batch, the 1 month trial plan is 2,250 rupees, and I felt very happy as one of the educators, in this out of these four. Okay. It has been already started on 12th of October 2020. If you are not enrolling now, please enroll immediately. But don't forget to use my code Maruti Live. Once you are applying my code, you will get 10% of instant discount out of the total money. That's all. Yes, coming to our topic, that is 6th year group elements. 6th year group elements part 3 it is, lecture 3. In the last class, we have discussed about the oxidation numbers. In the last session, we have discussed about the oxidation numbers and oxy acids, I think. Oxy acids also we have already discussed, right? Now we are going to discuss about the hydrides. hydrides of 60A group elements. Hydrides. What are the different types of hydrides will be formed here? So hydrides key, there is a general formula we have. There is a general formula for hydrides. They are all like oxygen, sulfur, selenium, tellurium and polonium. All these hydrides can form H2M or MH2 type of hydrides will be formed. So if you write like this, how can you write like this? H2O, H2S, H2SE, H2TE and H2PO. Like these type of hydrides will be formed by all these 60A group elements. 60A group elements. How can you produce water as well as how can you produce hydrogen sulfide in laboratory? Very simple techniques we have. What are the simple techniques? See here. You can produce the H2O simply by reacting it with sodium oxide with HCl. Sodium oxide with HCl. Of course, two sodium chlorides will separate out and our required product like water will comes out. So water will be separating out or water will be produced by the reacting of sodium oxide with HCl. In the same way, iron sulfide, when it reacts with the strong acid like sulfuric acid, you will have FeSO4 ferrous sulfate along with H2S. Likewise, you can take the metal oxides or metal sulfides or metal selenides or metal tellurides with strong acids like HCl, H2SO4 or HNO3 etc. and etc. When you react these metal oxides or sulfides with the acids, you will get H2O as well as H2S or H2SC or H2T etc. and etc. That's all. Okay. Coming to the next one. Suppose if you take any of the hydrides like MH2 or H2M. What about the shape of this MH2 or H2M? The shape is bent or the shape is angular. The shape is either angular or bent shape. Suppose if you take H2O, how the H2O will be looks like? H2O is looking like this. What about the bond angle? It is 104 degrees is the bond angle. And what about 104.5 or 104 degrees? And what about the hybridization of oxygen? The hybridization of oxygen is sp3. But with respect to the VSEPR theory or according to the VSEPR theory, here there is two lone pairs. Based on the repulsion of the lone pair and lone pair, the tetrahedral shape is completely converts to the bent or angular shape and the 109 degrees is slowly reduced to 104 degrees. That's all. Okay. In the case of H2S, H2SE and H2TE, what about the hybridization of sulfur, selenium and tellurium? In this, oxygen can have sp3 hybridization, but in the sulfur, selenium and tellurium, there is no hybridization at all. There is no hybridization at all. Without hybridization, how the molecules will be produced? Without hybridization, how the molecules will be produced? I will give the correct reason. See here, if you take the sulfur, sulfur equals to 16. So 1s2, 2s2, 2p6, 3s2, 3p4, right? 3s2 and 3p4. 1, 2, 3 and 4. Okay. How many p orbitals are there here with the unpaired electrons? There are two p orbitals are there with unpaired electrons. This is py and it is pz. So I will write the p orbital diagrams here. Okay. This is py and it is pz. So py reacts with one hydrogen and pz also reacts with another hydrogen. Py reacts with one hydrogen, it is py, it is pz. Py reacts with one hydrogen and pz reacts with another hydrogen. So these two will form with a bent shape. These two will form the bonds with a bent shape. It is not at 104 degrees, it is approximately 90 degrees. Why? Because px as well as py as well as pz, these three are perpendicular to each other. These three are perpendicular to each other. So this Py as well as Pz orbitals are looking like 90 degrees. They are perpendicular to each other. So this H2S or H2Se or H2Te, these three bond angles are nearly 90 degrees. If you observe the bond angles for H2S, it is 92.5 degrees, whereas for H2Se it is 91 degrees, whereas for H2Te it is 90 degrees. It is 90 degrees. So the bond angles are almost equal to 90 degrees. They are almost equal to 90 degrees. But for H2O it is not equal to 90 because the oxygen is undergoes hybridization of sp3. Oxygen is undergoes sp3 hybridization, so it will not forms the pp pure. In the H2S and H2Se and H2Te there is no hybridization, but the bonds will be formed with the help of pure p orbital. So it is very important for us, very important. So with the help of pure p orbitals only, H2Se, H2Te and H2S will be forms the H2 the bonds with bond angles equal to 90 degrees nearly. Clear? Very good. Coming to some important orders. I am discussing the order of volatile nature first. I am discussing about the order of volatile nature. What about the order of volatile nature here? Here the volatile nature will be H2, will have very high to the H2S, then it is H2SG, sulfur, selenium, next tellurium, and the least one is water molecules. Why the water is having very least volatile nature? Because water is having intermolecular hydrogen bonding. Water is having intermolecular hydrogen bonding. Suppose if you take the water like this, H2O, H2O and H2O like this. ఇలా తీసుకున్నారు అనుకోండి, in which this hydrogen will be bind up with the highest electronegative atom like oxygen in the other molecule with intermolecular hydrogen bonding. It is also an intermolecular hydrogen bonding. So in between the oxygen and hydrogen there are intermolecular hydrogen bondings will be produced. So based on the intermolecular hydrogen bondings, the boiling points will be increased, thereby the volatile nature will be very less. So this is the order of volatile nature. Coming to the next one, order of stability or order of boiling point we will observe here. Order of boiling points. These are very important with respect to EAMCET point of view. Order of boiling points. How the boiling points will be there? See here. Order of boiling points. H2O is having highest boiling point, then H2Te, and after that H2Se, and finally H2S. That means the order of boiling points are completely reverse to the volatile nature. These two are completely reverse because once the hydrogen bondings will be there in the water molecules, then you have to give more amount of temperature to boil the H2O molecule to convert it into vapor. That means volatility. The volatile nature is very less, so the boiling point is very high. That's all. This is the case how the volatile nature as well as boiling points will be there to all the hydrates of the 6th A group elements. 6th A group elements. Okay. Then coming to the next one, that is order of Ka values. Order of Ka values. Ka means Ka is nothing but equals to dissociation constant of acid. Ka is nothing but dissociation constant of acid. It is called as Ka, dissociation constant of acid. Okay. How the dissociation constant of acids will be there? I will give the priority order to you. See here. I am taking H2O, H2S, H2Se and H2Te. See here, Ka value means dissociation constant of acid. So which molecule can easily donate the hydrogen that is having most amount of Ka values? Which molecule can easily donate the hydrogen? That molecule can easily called as Ka dissociation. The molecule is having a highest acidic nature. See, the acidic nature is looking like this. That means Ka value is looking like this because here the tellurium is very biggest atom. Once the tellurium is having biggest atom, what about the remaining hydrogens? This is and this is. These two are hydrogens. So this is the nucleus of tellurium. Okay. The internuclear distance will be increases. Thereby the bonds will breaks up. Automatically the hydrogens will goes out from the tellurium. Thereby it is having more acidic nature because it can donate the H plus ions. H2Te can donate the H plus ions. So the losing of H plus ions is called as acid. So the dissociation constant of H2Te is very high, whereas H2O is very less because oxygen is very less atomic size, is having very less atomic size. Oxygen is having very less atomic size, and this is one hydrogen, it is the other hydrogen. So the internuclear distance is very less, so the bond will not breaks easily. The bond will not breaks easily. So hydrogen cannot be produced from the water. It is neutral of course, but H2Te is having some acidic nature. That's all. Coming to the next one. Order of stability. Order of stability. How the order of stability will be there? Suppose if you observe the H2Te, H2Te can easily dissociates into H plus as well as Te. So it can easily donate the H hydrogens. It can easily donate the hydrogen. So H2Te is more acidic. So dissociation can be easily done in H2Te but not in H2O. So what about the stability of H2Te? It is very less. It will completely dissociates, but H2O cannot easily dissociate. So the stability order of the hydrides are looking like this. It is completely reversed to the order of Ka values. Okay, compare with the Ka values of all the hydrides of 60A group elements and compare the stability of order of the 60A group elements, then it is completely vice versa. They are completely reversed with each other. These are the important concepts about the hydrides. They are all completely about hydrides with respect to EAMCET point of view. Coming to oxides, very important oxides are there. See here, yes, some of the oxides are simple oxides, some of the oxides are superoxides, some of the oxides are suboxides, some of the oxides are sesquioxides. What are these? Let us discuss one by one. So one is simple oxide, second one is superoxide, third one is suboxide, and the last one is sesquioxide. What is meant by sesquioxide? It is very important with respect to EAMCET point of view. Sesquioxide means the number of oxygens. The number of oxygen should be 3 and the number of metal atoms. The number of metal atoms should be 2. The number of oxygen should be 3 and the number of metal atoms should be 2. Suppose if you take the best example like Al2O3, here the metal atoms are 2 but oxygen atoms are 3. So Al2O3 is the sesquioxide, Cr2O3, Fe2O3. These are all called sesquioxides. So sesquioxide means hi, good afternoon, welcome to Unacademy platform, YouTube channel. Thank you, thanks for coming. This is called as sesquioxide. Okay, very important it is. With respect to EAMCET point of view, it is very important. So sesquioxides means the number of oxygen atoms should be 3 and the number of metal atoms should be 2. they are called sesquioxides. They are all called sesquioxides. Coming to the suboxides. Suboxides means, suppose if you take normal oxygen atoms, if you take any of the molecule like carbon dioxide, if you take the normal carbon dioxide like this. So in this carbon dioxide, how many oxygen should be there? 2 oxygen should be there. But in suboxides, it is not super, it is suboxide. Suboxide means the number of oxygen should be less than the sufficient. Less than the sufficient. Suppose if you take sulfur dioxide, it should like it should looks like SO2. It should looks like SO2. SO2 laga kanipistundi, right? But but the sulfur suboxide is S2O. That means the number of oxygens will be less. The number of oxygens will be less than the sufficient. Number of oxygens will be less than the sufficient. In the same way, suppose if you take the carbon oxides are C3O2. These are all the best examples for suboxides. Suboxides. Okay. And coming to the superoxides. Superoxides means superoxide. The best examples for the these examples are very important with respect to EAMCET point of view. KO2 is a superoxide. KO2 is a superoxide. Okay. And RB, rubidium oxide. CSO2, cesium oxide. These are all the best examples for superoxides. And one more important thing is, these superoxides are having paramagnetic property. These superoxides are having a paramagnetic property. Now coming to the simple oxides, very important example, very important concept of course suboxides may not be occur in EAMCET point of view, but superoxide and sesquioxides are very important. And simple oxides also. Simple oxide means simple oxides. So many number of simple oxides we have. Let us discuss the classification of simple oxides. Some of the simple oxides are basic oxides. Some of the simple oxides are acidic oxides. Some of the simple oxides are neutral oxides, and some of the simple oxides are amphoteric oxides. So there are 4 different types of simple oxides we have. Let us discuss one by one. Okay. Coming to the basic oxides. Basic oxides. The best examples for the basic oxides are Na2O. Okay, sodium oxide, because this oxide, when it dissolves into the water, it will produce strong bases. That's why this oxide is called basic oxide. This is called as basic oxide. Suppose if you take magnesium oxide, calcium oxide, copper oxide, these are all will forms bases when they are when they are dissolving it in water. Okay, that's why these are all called basic oxides. They're all called basic oxides. Hi, complete gaming. Are you there or not? Hello. Right. Next, coming to the next one, that is acidic oxides. Acidic oxides. Acidic oxides means that the type of oxides which can dissolve into the water and forms acids. They are all called acidic oxides. Suppose if you take carbon dioxide, it will produce carbonic acid. Okay. And in the same way, if you take NO2, it can produce nitrous acid and nitric acid. It's a mixed oxide. It is actually. It's a mixed oxide. NO2 is a mixed oxide. It can produce both HNO2 as well as HNO3 and P4O6 as well as P4O10, like that. N2O3 and SO2, SO3. These are all will be produced the acids when it dissolves in water. That's why these are all called acidic oxide. These are all called acidic oxide, right? And coming to the next one, that is amphoteric oxide or neutral oxide. First of all, we will observe, then we will go for amphoteric oxide. Neutral oxides. What are neutral oxides? What are neutral oxides? Neutral oxides means they neither reacts with the hydrochloric acid, that means acids, or they neither reacts with the bases. It cannot react with both acids as well as bases. That type of oxides are called as neutral oxides. Suppose if you take carbon monoxide, it is a neutral oxide. It cannot react with acid or it cannot react with bases. Suppose if you take nitrous acid, that means laughing gas. N2 is called as laughing gas. So this laughing gas cannot react with acid as well as base. In the same way, NO, H2O, etc. These are all completely neutral. They neither reacts with acids nor reacts with bases. Such type of oxides are called as neutral oxides. Such type of oxides are called neutral oxides. And the last one is amphoteric oxide. Amphoteric oxide. What is the meaning of amphoteric oxide? It can easily neutralizes the acids as well as bases. So the substances or the oxides which can easily react with acids as well as bases are called amphoteric oxides. They are called amphoteric oxides. Amphoteric oxides. Suppose the best examples for amphoteric oxides are Al2O3, alumina. It is an amphoteric oxide. And zinc oxide, ZnO, it is a amphoteric oxide. And PbO2, lead oxide is an amphoteric oxide. Chromium oxide, Cr2O3 is an amphoteric oxide, like that. So these are all. These can react with both acids as well as bases. Suppose if I am taking one example like ZnO. If I am taking one example like ZnO. See here, this ZnO is an amphoteric oxide, you know very well. An amphoteric oxide, so it can react with both acid as well as it can react with both bases also. It is an acid, you know very well. HCl is an acid, NaOH is a base. This zinc oxide is amphoteric oxide. Okay, so once this zinc oxide reacts with HCl, it will produce ZnCl2 plus H2O. In the same way, this zinc oxide reacts with sodium hydroxide. Hi Leela Krishna, good afternoon. The time is almost over. Anyway, please, thanks for coming. Please subscribe it, like it, and share it. Please, దీన్ని జాగ్రత్తగా చూడు మొత్తం వీడియో ఫస్ట్ నుంచి లాస్ట్ వరకు. It is very important bits are have been covered in this session. So when the zinc oxide reacts with sodium hydroxide, it will produce Na2ZnO2. It is called as sodium zincate. It is called as sodium zincate. Of course, along with H2O will separate out. Okay, so this zinc oxide is nothing but equals to an amphoteric oxide. That's why it can easily react with both acids as well as base. That's why it is called as amphoteric oxide. That's all. So today we have discussed about the hydrides. Yes, the hydrides of 7th A group elements and the hybridizations of hydrides and bond angles of hydrides. And why the pure p orbitals, how the pure p orbitals will be participates in the bond formation for all the hydrides we have discussed, and order of volatile nature, boiling points, Ka values, and stability also we have discussed. And we have already discussed about the oxides also. Oxides. There are 4 different types of oxides. We have simple, super, sub, and sesquioxides. Okay. Sesquioxides means number of oxygen should be 3, number of metal atoms should be 2. They are called sesquioxide. And simple oxides are also having 4 classifications: basic, acidic, neutral, and amphoteric oxides. So how the amphoteric oxide will works also we have already seen. That's all. This is our today's session. So I think it is very helpful to you in the case of EAMCET point of view. And in the next session we will discuss about the last concept of this 6A group elements, that is sulfur dioxide, and after that preparation of ozone and sulfuric acids. That's all. After this, we will complete the this 60 group elements. That's all. Until then, keep watching my videos. Thank you. Bye bye.